Have you ever watched the weather forecast and heard someone say, "Hurricane Olivia is heading toward the coast," and wondered, who gave that giant storm a name? Was there a secret meeting somewhere? Can scientists really predict where a storm will travel days before it arrives? Or is nature simply too powerful to predict? Today, we're stepping inside the fascinating world of meteorology to uncover the science behind storms and discover how forecasting helps protect millions of people around the world. Welcome to Science Meets Adventure, where science fuels every journey. Every great storm begins with something surprisingly small. Imagine a tiny spinning seed floating over a warm tropical ocean. The sun heats the water, causing warm, moist air to rise high into the sky. As the air rises, it leaves behind an area of lower pressure, almost like creating an invisible vacuum. Nearby air rushes in to fill the empty space, bringing even more warm, moist air with it. Higher in the atmosphere, the moisture cools and forms clouds, releasing heat that gives the storm even more energy. As Earth spins, something incredible happens. The planet's rotation gently bends the moving air, causing it to begin spinning. This effect, called the Coriolis effect, is like trying to roll a ball across a spinning merry-go-round. The ball doesn't travel in a straight line, it curves. In the same way, winds begin wrapping around the center of the storm, transforming a simple cluster of clouds into a rotating weather system. At first, it's called a tropical depression. If the winds become stronger, it earns the title of a tropical storm. Once the winds reach about 74 miles per hour, or 119 kilometers per hour, it becomes a hurricane in the Atlantic and Eastern Pacific, a typhoon in the Western Pacific, or a cyclone in the Indian Ocean and South Pacific. Different names, but they're all the same powerful type of storm. But here's where things get fascinating. Who decides these storms deserve names in the first place? Long ago, storms were often identified only by the place or date where they struck, making weather reports confusing. Imagine trying to remember the big storm from September when several storms happened that month. Meteorologists realized that giving storms short, memorable names made warnings much easier to understand. Today, international weather organizations work together using carefully prepared lists of names that rotate every few years. If a storm becomes especially deadly or destructive, its name is permanently retired out of respect for those affected. That's why you'll never see some famous storm names used again. Giving storms names is about saving lives. When people hear a clear, recognizable name repeated across television, radio, websites, and weather apps, they pay attention much faster. So how do meteorologists know where these storms are going? Think of weather forecasting as solving one of the world's biggest puzzles. High above Earth, satellites continuously watch our planet from space, taking detailed images day and night. They track cloud movement, measure temperatures, and monitor developing storms over vast oceans, where few people live. Closer to the ground, weather radar sends out invisible radio waves that bounce off raindrops, helping scientists see where heavy rain and strong winds are developing. Weather balloons rise high into the atmosphere, carrying instruments that measure temperature, humidity, air pressure, and wind speed. Floating in the ocean, thousands of weather buoys record sea temperatures and wave conditions, sending valuable information back to forecasting centers. Sometimes, scientists gather data in the most exciting way imaginable. Special aircraft known as hurricane hunters actually fly directly into powerful storms. They release instruments that measure wind speeds, pressure, humidity, and temperature from inside the storm itself. It sounds unbelievable, but those daring flights provide information that satellites alone cannot capture. All of this information is fed into enormous computer models. These supercomputers perform millions of calculations every second, testing countless possibilities to estimate where the storm may travel over the coming days. But the real mystery is just beginning. Why don't storms always follow the first predicted path? The answer is that storms don't travel by themselves. They're carried along by giant air currents high in the atmosphere, almost like leaves floating down invisible rivers in the sky. Large areas of high pressure can block or redirect a storm. changes in ocean temperatures may strengthen or weaken it. Dry air can slow its growth, while warm water gives it fresh energy. Even small differences in atmospheric conditions can gradually shift a storm's path hundreds of miles over several days. That's why forecast maps often show a widening cone instead of a single line. The farther into the future scientists predict, the more uncertainty there is. Forecasts are constantly updated as new observations arrive. Here's something most travelers never realize. Storm forecasts aren't only for people living near the coast. They help hikers decide whether it's safe to explore mountain trails. Sailors choose safer routes across the ocean. Cruise ships adjust their itineraries days before dangerous weather arrives. Pilots avoid areas of severe turbulence. Road trippers delay long drives. Photographers chase dramatic skies safely. And outdoor adventurers know when it's time to explore and when it's smarter to wait. One accurate forecast can protect an entire vacation, an expedition, or even save lives. And the amazing weather facts don't stop there. Some tropical storms grow larger than entire countries. At the center of many powerful hurricanes is the Eye, a surprisingly calm area surrounded by the most violent winds on Earth. Weather satellites orbit our planet every hour of every day, constantly watching changing conditions. Hurricane hunters intentionally fly into storms that most people would run away from. Thanks to better satellites, faster computers, and improved forecasting techniques, today's storm predictions are far more accurate than they were just a few decades ago. This is where science becomes incredibly powerful. The future of storm forecasting is becoming even more exciting. Artificial intelligence is helping scientists recognize weather patterns faster than ever before. New generations of satellites capture sharper images with incredible detail. Supercomputers continue growing more powerful, allowing forecasts to become increasingly precise. At the same time, climate researchers are learning more about how changing oceans and atmospheres may influence future storms, helping communities prepare for whatever lies ahead. Every forecast represents thousands of scientists, engineers, pilots, technicians, and computers working together with one goal: helping people stay safe while continuing to explore our amazing planet. The next time you hear that a storm has been given a name, you'll know there's an incredible scientific story behind it. From a tiny swirl of warm ocean air to a massive rotating system visible from space, every storm follows the laws of nature. And thanks to modern meteorology, we can understand those laws better than ever before. If you enjoyed today's adventure, don't forget to like, share, and subscribe to Science Meets Adventure so you never miss another incredible journey into science and exploration. See you in the next adventure!